In this video, we're going to be talking about solving trigonometric equations, and we're going to start with some simple ones here. I'll be looking at some more complex ones when we have our class meeting on Wednesday. The first thing we want to talk about is notation. So remember that this -1 that looks like an exponent is actually our inverse notation. When we have an inverse trig function, we're solving for an angle measure that corresponds to a particular value. The other thing that we have to think about and be aware of are the limitations that we have on our cosine function due to the need to have a one-to-one function. So if we go back to our table for a cosine function, we see that in order for cosine functions to be one-to-one, we need to be looking at angles in between 0 and pi. So I need an angle measure in between 0 and pi, so first and second quadrant. That's going to have an angle measure, a cosine value of negative radical 2 over 2. In order for a cosine value to be negative and be limited to 0 to pi, we have to be in the second quadrant because our x values are negative in the second quadrant. So the angle measure that would correspond to this would be 135 degrees because its reference angle is 45 degrees from the first quadrant. So the solution to that equation is 135 degrees. Or you could say that if it's in radians, we would be at 3 pi over 4. So that's really all that we're doing and thinking about while we are looking at these types of functions. So for a sine function, sine has to be between negative pi over 2 and pi over 2 in order for the graph to be one-to-one. So negative pi over 2 and positive pi over 2 are actually in the first and fourth quadrant, first and fourth, here and here. We want a sine value that is positive. So for a sine value to be positive, then our solution has to be in the first quadrant. So we want a sine value that has an angle that has a sine value of 1/2, and that angle is going to be at 30 degrees. Or pi over 6. Now we're not done here because we actually have to take and finish solving. So we found the inverse sine of 1/2, and now we have to take and solve for the cosine value at pi over 6. The cosine value at pi over 6 is going to be radical 3 over 2, and that would be your final answer. So you can use your unit circle to help you with these values that are the nice increments on the unit circle. If they were ones other than your unit circle value, then you would need to use your calculator and your inverse trig function on your calculator to solve. And you need to make sure that you're in the correct mode, whether that is in degrees or radians. So these again are your restrictions. You want to make sure that you kind of have these in your head as you're working with and solving some of these equations as we get into some more complicated ones. So the last example that we're going to look at today is to find the value of x between pi and 3 pi over 2 that solves the secant of x is equal to 1/2. So just to make sure that we're remembering all of our unit circle values, this would be pi and 3 pi over 2. So we know we're working somewhere in the third quadrant to find an answer. So secant of x is equal to -2. I don't really know much about secant values off the top of my head, so I want to think about this as an identity. So you can also use your identity functions to help you solve trig equations. So secant is going to be 1 over the cosine of x is equal to -2. Well, I don't want cosine in the denominator, so I can actually take and find the reciprocal of both sides of that equation. So I have to flip both of those. So the cosine of x is equal to -1/2. So the question I'm asking then would be, what is the angle measure that is going to give me a cosine value of -1/2 if I'm in the third quadrant? You can use your reference angles to help you with this. So if you remember that in the first quadrant, the cosine at 1/2, that angle measure is going to be at 60 degrees. So that's your reference angle. So in the third quadrant, I would take also a reference angle of 60 degrees. So 180 plus 60 would put me at 240 degrees. And if it was in radians, you would take and make sure that you had your answer in radians. So this is why making sure that you know that your unit circle values is going to be really helpful and important for using and solving equations. So if you haven't finished memorizing that, now would be a great time to go back and do that. The last thing that we want to talk about would be finding a solution. So there's two ways that you'll be asked to find a solution for a trigonometric equation. The first is when they give you a specific interval, and you're going to solve for the angles that satisfy the given conditions only. So again, sometimes you have to go back and think about what quadrant you should be in based on that other slide. You know, that sine is going to be between -pi/2 and +pi/2, and cosine should be between 0 and pi and all of that good stuff. If you're asked to find a general solution or all solutions, that means that you're solving for angles that satisfy the given conditions in the restricted domain and appropriate multiples of the interval. So that's where we have to go back and say things like that this is going to occur at pi/2 plus every interval of pi. And so you would say k pi. And again, we'll look at some more specific examples of that when we have class together this week.